Okay, Assalamualaikum and hi everyone. So how are you doing today? Okay, now let's continue with our last lecture for chapter 6 polynomial with our subtopic 6.3 partial fractions. Okay, so this is our lecture 5 of 5. Okay guys, let's look at our learning objective for today. Okay, before I want to continue with our today's lecture, let's look at our objective for the last lecture. Okay, for the last lecture, you did learn how to construct partial fractions when your denominators comes in the form one linear factor ax plus b and the repeated linear factor ax plus b to the power of n. Okay. So you already know for this one, but for today we will learn new things. All right, so let's look at our objective. By the end of this lesson, you should able to construct partial fractions decomposition when the denominators are in the form of quadratic factor, which is ax squared plus bx plus c. So our denominator will comes in form of quadratic. Okay, but for quadratic we will have two types. Okay, so let's look at for the rest of lecture so that you know what we are going to learn about. Okay, 6.3 partial fractions. Before we go to type 3, let's look at what do we have for type 1 and type 2. Okay, type 1 we have linear factors only. So for linear factors you can just separate them, okay, with the constant ABC. For type 2, repeated linear factors, you will have either, you have inside is the linear factor and you have the power outside. So for this one, as you can see here, x plus 5 power of 2, you will rewrite them as x plus 5 power 1 plus x plus 5 with power of 2 with difference constant. Okay, so this is what we call repeated factors. So that's mean that for linear factor, you can just rewrite them. But for repeated linear factors, we have to rewrite according to the increasing power. So we start with a power of 1, power of 2. Okay, for example there. Okay, now let's look at our type 3. Okay, type 3 is the quadratic factor in the denominator. Okay, quadratic factor in the denominator. Okay, quadratic factors comes into two parts, which is the first one can be factorized. All right, the first one is can be factorized. The second one, quadratic factors that cannot be factorized. So we will have two different steps there. Okay, let's look at the denominator with quadratic factors that can be factorized. Okay, for this one, when you can factor, the first thing, when you got the equation, you will get in form of quadratic. So we need to check whether it can factor or not. If it can factors, okay, your equation may turn into part 1 or it can turn into part 2. It depends on the equations, okay? Or it can turn to part 1 and 2 at the same equations, okay? So we will look at later on our exercises, okay, on our examples. So let's look at number 2. Denominator with quadratic factors that cannot be factorized. That means you can't factor it at all. You can't find the value of x. So what we can do, we have to solve it in new way, and maybe at the same equation you also have part 1 and part 2 inside them. Okay, that's come together inside the equation. Okay, but for the quadratic factor that cannot be factorized, we will rewrite them with the new constant equations on the numerator. So don't don't be confused, because later you will understand during our examples. Okay. Right guys, so here let's look at a bit about quadratic factors. Okay, let's review back. Okay, for quadratic factors, what will involve is either it can factor or you need to expand. Okay, these two is a close connection with quadratic factors. Okay, so what is factor and what is expand? Okay, let's say let's look at what is expand. All right, expand. Okay, I give you an here x plus y power of 2. Okay, for you to expand, we just take the first term and the last term, which is plus y squared, and then in the middle is the just multiplication of all term, which is you have 2, you have x, and you have y. So here it will be positive 2xy. Okay, another one, we have x minus y squared. Okay, as I said before, we just take the first term and the last term plus negative y power of 2. Okay, and in the middle, you just put the multiplication of all terms, which is you have plus 2 multiplied by x multiplied with a negative y there. All right, so let's complete the solution here. It will be x squared minus 2x squared. Here negative y power of 2, so we will have y squared. Okay, that's what we call expand. Okay, for factors, all right, for factor, okay, how you can factor? Actually, we do have like standard form of factor. Okay, if you have a square minus b square, you should know how to factor this one. Okay, it is actually the form will be as a plus b bracket a minus b. Okay, this is the standard form actually for you to factor this one. If you have the form of a square minus b square, you will change, the value is still the same as a and b. One bracket will have plus, another one will have minus that. Okay, how do we understand this one? Let's prove it. All right, let's prove it. You have a plus b, a minus b. Let's expand one by one. So you will have a square minus ab. All right, settle that one first, and then b we settle with b. So you have ba minus b square. Okay, so here a square minus ab plus ba. It's just the same thing because you just multiply with each other. So here it will cancel to 0. And what do you have at the end? A square minus b square. Okay, so for this one, it's actually you need to, because we already proved it. All right, proven. All right, it's proven. So you have to, now we understand for this one, and it's for us to remember for this part in order for us to factor easily. Okay. Okay, so let's look at example 1. Alright, example 1. Express x over 4x squared minus 1 in partial fractions. Okay, as I taught you on the last video, okay, we need to identify what is the denominator first before you start. As you can see here, you just only have one things here. So what is this? So here is quadratic factors. Okay, for quadratic factors, your first step should be you check the quadratic factors. All right, so we check for x squared minus 1. Can it be factorized or cannot? That is our question marks. Okay, so for x squared minus 1, let's think, guys, can you factor it or not? Okay, I can see here a 4 is the same as 2 power of 2. All right, and x squared, and 1 is the same as 1 squared. So I can change it to another form, which is bracket 2x power of 2 minus 1 squared. Okay, why do I want to change to this one? Do you guys remember just now we just learned about the standard form, which is when you have a squared minus b squared, it is just the same as a plus b multiplied with a minus b. This is our standard form of factor. Okay, why do I think it is similar as this? Because you see that it is minus minus, and you can change them into power of 2, and at the end you get the same form as this one. So it is actually, you can factor it. So let's rewrite them in form of factor. So we have 2x squared minus 1 squared is the same as 2x plus 1 multiplied with 2x minus 1. So our conclusion is it is the quadratic factor that can be factorized. Okay, so next we will continue with writing back our equation. So we have x over 4x squared minus 1 is equal to, okay, for this part we just change the equation first. Okay, so here you change the quadratic factor into quadratic factor that can be factorized. Okay, that means we change the original equation into this is the original equation, okay, into the form that we can factorize it. Okay, so here the green box here is what you have to start with for us to find the partial fractions. Okay, so we just change the original equation into simplest form, which the quadratic factors at the denominator can be factorized at the end. Okay, here let's rewrite them. We don't need anymore the original equation, because for original equation we can't solve it until you can change into factors. So here our equations will change into x over 2x plus 1, 2x minus 1 equal to. Okay, now guys, what is this one and what is this one? Here is linear factor, here is linear factor. This is type 1 and this is type 1. So actually you can just calculate like usual that we learned before. Alright, just separate them because it is just linear factor and you have a and b. So here we can find our a and b. Okay, so for us to find a and b, just multiply with another linear factor so that we can get the same denominator. So here you will multiply with 2x minus 1, 2x minus 1, and here is 2x plus 1, 2x plus 1. Okay, next step, write down as, because our denominator is the same, so we can just write down the numerator. Okay, so here is your new equation that we can use for us to find our a and b. Alright, so we will go back to our steps before. Okay, number 2, we just substitute the value. Alright, so you have 2x minus 1, you will substitute with x equal to 1 over 2. Okay, let's substitute the value that you have. We have 1 over 2, right? To the left hand side, 1 over 2, you have a. Okay, because it has the same factors there, when you substitute this value, it will get 0, so automatically 0. So b, you have 2, 1 over 2 plus 1. So here you will have negative. Okay, so here let's calculate. You have 1 over 2 equal to b. What do you have here? You have plus 2b. So b is equal to 1 over 4. Okay, am I right? Let's check back. You have 0 here. Okay, here, so you have 2, 1 over 2, 1 plus 2b. Okay, next, you have 2x plus 1. So we will substitute the value of x equal to negative 2. Okay, am I right? Okay, so let's put the value negative 1 over 2 is equal to a multiply with 2, negative 1 over 2 minus 1 plus b. It has the same factor, automatically will be 0. Okay, so negative 1 over 2. Alright, so you have negative 2a, so a is equal to 1 over 4. Okay, so we got our aim here. You got a, you got b. Okay, what is left? Okay, what is left is our final step. Okay, actually arrangement of step here is quite it's wrong, like I said before. Number 1 is you equal the denominator. Number 2, you equal the numerator. We compare the numerator as the denominator is the same. Number 3, find the value. And our last step, our fourth step, what is the class, is just rewrite back the equations. Okay, here your equations is actually the original one. Okay, we can, okay, let's rewrite them as the one that we factor. Okay, it's equal to a is equal to 1 over 4, so you have 1, 4, 2x plus 1 plus 1 over 4, 2x minus 1. Okay, it's just the same as you want to rewrite them as the original one, x for x squared minus 1. Okay, you can also rewrite them using the original equations. Okay, it is equal to 1 over 4 to x plus 1 plus 1 over 4 to x minus 1. Okay, let's look at this box. You can either rewrite as this one. Okay, why? Because we already show it is equal to the equations here. Okay, we already show here. Or you can also rewrite them as original equations, okay, equal to what we can to the partial fractions.